Welcome to the last part of this tutorial. Now, what we want to do is to do the demodulation and then present the signal that we receive at the end of our receiver. And then what we want to do is to compare the transmitted signal or the signal that is generated in the random source block and the signal that we have demodulated. So what we can do next is to add the modulation block. Here we have different options. Some of them has been already deprecated. So in this case, what I'm going to do is to use, even though it's deprecated, I'm going to use this PSK block, but we can also use, for instance, a quadrature block, and the results should be more or less the same. So in this case, what we are going to do is going to rotate this block to make easier its usage. So we are going to connect the output of the Costas loop, and we are going to modify the number of constellations as we have only a QPSK transceiver. So basically the number of constellations that we have seen through this tutorial is just 4. We maintain the samples per symbol in 2, and we leave the rest of our parameters as they are defined. Then what we have to do is to use this symbolic coding, in which we are going to tell what are the symbols that we have used. What is our symbol map? Here in the constellation object we have defined it already. So what we have to say is that the symbol map that we are going to use for these applications is going to be 0, 1, 2, and 3. And then what we have to do is to use a filter, differential decoder, and what this differential decoder does is to translate the symbols to the origin, the received signals to the symbols that we have sent here in the transmitter part. So we are going to assign a modulus of 4. Why 4? Well, because we have only 4 symbols, or 4 constellations, sorry, and we have finally to use an unpack k-bit, sorry. And with this block, what we are going to do, as it says, is that we are going to convert a byte with k relevant bit to k output byte with 1 bit in the LSB, low significant bit, least significant bit. So in this case, our k is going to be just 2. Now what we want to see is the outcome of these blocks. And to do this, basically what we have to do is to add a time sink. However, as you can see here, the time sink only accepts as input bytes or float numbers. So in this case, what we have to do is to use a converter. We are going to convert char to float, because there is no conversion to char to byte, and as a consequence, we are going to change here is the type of our input. We connect those blocks out, and we assign the value to here, And what we get here is our output. Now the question that arises in this moment is whether this output corresponds to the input that we introduce using our random source. So what we are going to do is a comparison of them. To do this, we have to use again this unpack kbits block, and we are going to repeat the procedure of adding a converter, and we are going to use as well another time sink that we are going to receive as input flow value. So what we have here is that in this case, as we are using here in the random source bytes, so we know that the k-bits has to be 8, and we connect those blocks out, and finally what we get in the outcome. But first, let me just adjust the values that we are going to see. And we are going to call this bit stream out receiver, and we are going to call this bit stream transmitter. Apply. And now what we are going to see is whether our bit streams in the transmitter and the bit stream in the receiver side, if they match. And as we are seeing right here, they do. As a consequence, we can say, I'm going to set this thing a little bit more beautiful because it's way too big. I'm just going to call this that it has a dimension of 2 instead of 4, and we repeat the same thing right here. And now let's go to see what's the result. So now what we can see is that what we send is basically the same as we receive, and with this result basically we conclude our tutorial. And thanks a lot for watching, and hope to see you next time in a new tutorial about the usage of SDR with a new modulation scheme in communications network 2. Thanks a lot.